Okay, now I am going to discuss a very simple mathematical problem or statistical problem on normal distribution. So the question here is, height of a data follows the normal distribution with the mean of 68 inches and standard deviation of 3 inches. What is the probability that a random selected adult male from the population is taller than 72 inches? Okay, so at first we will try to draw the normal curve and try to see what is happening here. So basically this is our normal curve, and the mean is mean of the normal distribution. Here the normal distribution can be written as mean and sigma square, which are basically the parameters. Okay, so here our normal distribution is having the mean of 3 inches and standard deviation of 3 inch sorry mean of 68 inches and standard deviation of 3 inches. So I'm just writing that. Now if I tell that here this is our mean of the normal distribution, that is of 68 inches. Let me just okay, so this is our mean, that is of 68 inches. Okay, and if I tell about the sigma is going to tell us the spread. Now so this is our, suppose this is our 1 sigma, that is 65. This is our 68, that is mu plus 1 sigma, that is 71. Here we have mu minus 2 sigma, that is 62, and here we have mu plus 2 sigma, that is 74, and here we have mu minus 3 sigma, that is 59, and here we have mu plus 3 sigma, that is 77. As per the empirical rule, we know that we have almost in between mu minus 1 sigma and mu plus 1 sigma, we have almost 68% data points, or we can also tell that 68.27% data point to be precise. In between mu minus 2 sigma, that is 62, and 74, we have almost 95.45% data points, and in between 59 and 77, that is mu minus 3 sigma, if I write it also, and mu plus 3 sigma, we have almost 99.73% data points. So from here we can also get the interpretation that we can also say it in this way, that a point lying in between mu minus 3 sigma and mu plus 3 sigma, or we may also say it in this way, that the probability of a point lying between mu minus 3 sigma and mu plus 3 sigma is 99.73%. That is obviously very high. That means, I mean, for most of the times the point will obviously lie in between mu minus 3 sigma and mu plus 3 sigma. This is not just for this mathematical problem. For any normal distribution, any data that follows normal distribution, you can actually apply these conditions. Now we are basically willing to convert this into a standard normal variate. What is a standard normal variate? Standard normal variate is a normal distribution, is a special case of normal distribution where the mean is 0 and the standard deviation of the variance is 1. This is the special case of normal distribution, which is known as standard normal variate. So what will be that curve looking like? That curve will be looking like this. If I draw, only difference between these two curves will be, here we have the mean of 0, this will be 1, this will be 2, and this will be 3, and this will be minus 1, this will be minus 2, and this will be minus 3. This will be the only difference. Okay, so we basically want this curve to be converted into this curve. Why? The question that is being asked here, that what is the probability that a random selected male from the population is taller than 72 inches. So suppose 72 is present in between here, some place here. Okay, this is 72 suppose. Now from the curve of the normal distribution, if we want to find out that what is the probability that a person or that adult male is taller than 72 inches, we require this area. This area is supposed to be calculated, that is after 72. If we are successfully being able to calculate this area, then we can answer. Suppose this area is 0.25. Okay, that means the probability that a random selected adult male from the population is taller than 72 inches is 25%. There is a 25% probability that the person or the random selected adult male will have the height more than 72 inches. But the question is, are we able to calculate the area? Basically, it is not possible to calculate this area. Why? Because we don't have any kind of table, or we don't have any kind of calculation to calculate this particular area. So what can we do? We can convert it into a standard normal variate. What will be the advantage in doing that? Well, basically, when we are converting into a standard normal variate, then we will basically have the table which will help us to find out this area. How? I will show you. At first, what will I do? I will just convert it into standard normal variate. I will convert this normal distribution which is already given in the question. I will convert it into standard normal variate. For converting it into standard normal variate, you have to just find out, or you have to just write, you have to just apply this. That is called x bar minus, sorry, I may be writing wrong. So probably 72 inches. No, this is the formula is, I mean, it is not bad. I have to just write x minus mu. Let me write it again, or let me just cut it. Yes. So the formula is x minus mu divided by sigma. If you apply this formula, any data point you can convert it into normal, or any data point of normal distribution you can convert into a standard normal variate by applying this formula. Okay, so I want to convert 72 inches into standard normal variate, so I will just put 72 in place of x. My mu, or population mean, is nothing but 68, which is given in the question, and my sigma is 3. So if I calculate this, this will come as 1.33. Now basically this is our point. Where is 1.33 located? If I want to draw 1.33 on this normal curve, this is now this curve is not existing anymore, right? This has become this now. Okay, because we have applied this formula, this transformation, so it has become this now. So 1.33 is some point here, right? 1.33. Now what do we require? We require this area to be calculated. That what is the probability that the adult male have the height more than 1.33 inches. Now we will ask, the question was given as 72 inches, more than 72 inches. What is the probability that the adult male has the height more than 72 inches? Now obviously that was the question given, but we have converted that 72 inches into a standard normal variate. Now our point is 1.33. So we want to know what is the probability that the adult male will have height more than 1.33 inches. Okay, so now what will you do? We have to calculate this area, right? This area which I have shaded by blue color, we want to find out the area. Now for that we have a table that is already being given to us, and that is called Z table. From that Z table we can calculate the area. Okay, now let me open the Z table. Probably this is not the one. Yes, this is the Z table that I was talking about. This is from minus. I require the positive Z score table. So this is our Z score table. If I take the screen, I will not be able to take the screenshot from here, but still, what is the point that we have? We have the point that is 1.33. So at first we have to find out the value of 1.3. Where is 1.3 located? 1.3 is located here. And after 1.3, now let me explain this. If we have the point as 1.33, you have to break it. You have to break it as 1.3 plus 0.03, right? If we add it, you will get 1.33. There is no problem in it. You will try to search this 1.3 on these positions of the z-score table, and this 0.03 we will try to find out on these positions of the z-score table. Now let's do it again. So we are going to find out 1.3 here and 0.03 here. What is the value that is coming up to be? It is 0.90824. This value is coming up to be here. So 0.90824. This is the area. Now there is a twist in it. Now let me tell you this twist. That this area which you have calculated is telling the probability 0.90824. This is telling the probability that the height, or I can denote height as x also, just for my advantage here. Now what is this probability telling us? This probability is telling us that the probability of the height, that is x, less than 1.33 will be 0.90824. The probability of x, or the height, less than 1.33 is 0.90824, but we require the probability that x will be greater than 1.33. We require the probability that x will be greater than 1.33, right? Now it is very easy to understand that we all know that the entire area under the curve, let me change the color, the entire area under the curve, the total area, I am talking about this total area. This total area under the curve is nothing but 1. The entire area under the curve is 1, right? So if I want to find out that what is the probability of x greater than 1.33, I will take the total area, that is 1, and I will subtract what is the probability that x will be less than 1.33. Very simple mathematics. I hope you will understand it. So now it will become, if I take this, it will become probably 9.2, or 1 minus 90. Let me take it as 1.1 minus 0.91. So it will be 0.9. Okay, 0.9 means 90%. So that is 90% probability that our value x will be greater than 1.33, or our height will be greater than 1.33. What was 1.33 denoting here? This 1.33 is nothing but it was the value of the it was the standard normal value of 72 inches. So this probability is also showing us that what will be the probability that the boy will be taller than 72 inches. Okay, which was given in the question. Okay, so that's how we can calculate from the z table. That's how we can calculate the probability that can be calculated as area. Okay, here the steps that I want to repeat again. At first we have to convert it into a standard normal variate. Your data point, you have to convert it into a standard normal variate. Okay, why do you have to convert it into a standard normal variate? Because for standard normal variate we have a table to calculate the area under the curve. When you require area, or when we are calculating area, when we are calculating the probability from a PDF, we just require the area, nothing else. We can't directly calculate it. We require the area to calculate the probability. And to calculate the area, normally normal distribution doesn't have that area given directly, but if you convert that normal distribution into a standard normal distribution, then we have a z-score table which can give you area as per this code. Okay, so I have just converted into a standard normal variate. Now I have the z-score, and as per that z-score I will basically have a area. As you can see, as per that z-score, here this is the z-score. As per this z-score I have to calculate that what is the probability of the variable is less than 1.33, but z-score give us the opposite thing. It tells us that what is the probability that x will be less than 1.33, or our height will be 1 point less than 1.33. So we have to just subtract it from 1, because the entire area under the curve is 1, and that's how we can calculate the area that x will be greater than 1.33. And what was 1.33? It is the standard normal conversion of 72 inches. Okay, so that's how we can calculate the area. I think it is done here. Yes, probably I haven't done something wrong. sorry, it was the calculation mistake. It was some calculation mistake here. Let me just it was 0.09 supposed to be, and it is supposed to be 9% only, not 90%. Okay, so you have to just calculate. There is simple calculation mistake there was there. Okay, so that's how we can calculate the probability using the normal distribution and using the standard normal variate.